Show the maximum number of third great-grandparents using combinations factorials. Now, you know that the easiest way to get to the answer is just to take 2 and the exponent will be the number of generations from yourself that you need to get to your either great-grandparent, right? And you know that's going to be 5 generations. Right, so this answer is easily done by finding 32. However, in this video, I'm going to show you how to use factorials to get to the same number 32. All right? So basically, factorials will involve finding the number of ways to get to a third great-grandparent, and that will give you the total number of third great-grandparents. So the first one that we know is we can get from the paternal line. So basically we will have 5 P's. First P will be your father, then your grandfather on your paternal line, and etc., etc., right? This is going to be just the paternal line. We know there's only one way in getting there, right? Because the P's cannot permute amongst thirds, right? It's not going to change one way of getting through your paternal line to get to your particular third great-grandparent. The second case, similarly, can be all the M's, which basically is the maternal line. There's also only one way in getting to your third great-grandparent using just the maternal line. Now it's going to be more interesting because if we're going to mix the P's and M's now, if we have, let's say, 1 P and the rest of them will be M's, now you have to see that you can either picture the P being in any one of these 5 spots, which should give you 5 ways of achieving that, right? So P's can be distributed in the 2nd place or 3rd place or 4th place or the last place, right? So 5 altogether ways in doing that. Now, how can you use factorial to confirm that? Well, you know that P can go any one of these. The first spot can be any one of these 5, right? So you know it's going to be factorial 5 factorial, summarizing that, because 5 for the first spot, 4 for the 2nd spot, 3 for the 3rd spot, 2 remaining for the 4th spot, and of course the last one only 1 letter possible for the last spot. But now you have to divide by the 4 factorial because you don't want permuting amongst the M's. And of course, the last one remaining is the 1 factorial, which is just the P in itself. And let's see what this answer gives us. So we know this is equal to 5, 4, 3, 2, 1. On the bottom we have 4, 3, 2, 1, and then 1 for the 1 factorial. We know the 4, 3, 2, 1 cancel out. So we're just left with 5. And that confirms the manual method of placing the P among any of these available 5 places. Same logic goes for single M against all the remaining P's, right? We don't have to do that same work. We know it's going to be 5 as well. Now if you have 2 P's, right? Suppose that you go to your father's line and then your grandfather's line, and all the rest will be females, right? How many ways can we use to have 2 P's and 3 M's to get to any number of third great-grandparents? Well, we know we're going to use, again, 5 factorial. But in order to not overcount using permutations, we have to divide by the 2 factorial, because P's cannot be permuted, right? That's not going to change the way of getting to wherever we want to go. And also no 3 factorial either, right? Because M's cannot be permuted amongst themselves. So know this is going to yield us 5, 4, 3, 2, 1, and this is 2, 1, and 3, 2, 1. 3 2 1's cancel out. 4 divided by 2 is just 2, so it's just 2 times 5, which is 10 ways, right? 10 ways. And same thing can be thought of with 2 M's, and the rest of them being P's, right? 10 ways there again. Now what is that? That's basically through your maternal line to get to your maternal grandmother, and then all the rest will be her father, and then that grandfather, and then great-grandfather to get to your third great-grandparent, right? So 10 ways, just the same as we did here. Now notice that you can't go further than this, because if you're gonna include 3 p's and the rest of them being m's, you're gonna basically repeat that, right? Because 3 p's and 2 m's, you will have overcounted that, right? So we stop there, and that should be everything, because if we don't go further, we repeat, that means we're going basically backwards until every one is a single letter, either M or P, right? So now we can just count everything, and then you're going to see that it's going to give us a total of 32. 1 plus 1, 5 plus 5, and 10 and 10. As you can see, this is 20, 5 plus 5 is 10, so 30, and then 1 plus 1. So that's going to be 32, third great grandparents. Alright, so I hope this video was fun and helpful. Thanks for watching. I hope to see you in my next video.